Thank you very much, Adam. Is this one on? Yep. Cool. All right. Hello, guys. Thank you very much. First of all, just like to say, hello, Thom Toogood. I work at Amazee.io. I'm a platform engineer. I realised just last night, actually, that this is my 8th consecutive Drupal South talk. Sorry, not talk, but event that we've been to, and I'm super excited today to be able to talk to you about an introduction to Kubernetes. So let's get started. So Amazee.io, just for those of you who don't know, we're an open source Docker-based hosting company. We've recently started a cluster here in Australia and won a few contracts here, and I've started just working there earlier in this year. We've got a couple of people in the Australia region. So if you're interested in how it all works and a bit about what we're going to be talking today, definitely come out and talk to us at the booth outside. So quickly, to discuss the agenda of today, we're going to give you a very high-level overview of Kubernetes. Just enough, it's a huge subject, but just enough to sort of understand what it talks about, where we're going to try and build basically a proof of concept of simplytestme. So next we'll move on to just the step-by-step guides, what we'll need, how that works. It's very much a proof of concept, I must warn you. The challenge was put in place, and I actually tried to make it the functionality work with the least amount of code, so we'll get in and show you that. Lastly, we'll give you a demo of how it all works once you've got the frame of reference on everything. So first of all, who here knows about simplytestme? So a few of you? Yep, cool. So for those who don't, it's an awesome service. It's running for about 5 years, I believe. It was built by Patrick D, a German Drupal developer. What it allows is basically testing of any Drupal project that's hosted on Drupal.org. Go to the site, pick a project, pick a version, launch the sandbox, and it gives you a full, basically, Drupal site ready to test. It's been really valuable for also testing patches and during the development process of Drupal itself. So what happened? Last year, 23rd December, Patrick tweeted this. Basically, the future of simplytestme was, at risk, and he's sort of moved on, done a lot more front-end node work, and decided that he's not involved enough in the Drupal community to be able to take on and maintain. So obviously, we've got a lot of feedback. A lot of people saying, "Hey, this is such an important service. It's crucial that we need to keep this going." So a lot of people obviously offered to help out, and what was put in place was there was a whole bunch of ideas talked about on how it could be changed, improved. Ended up that Adam Bergstein has taken over full maintainership and kept the status quo. So it's still powering along, and everything's all go. So this basically prompted the project that we're going to talk about today. It was really just about, hey guys, we've got this awesome system. There's a new tool out there, Kubernetes. How can we utilize that potentially to replace the functionality? Before I start, I just wanted to acknowledge, 2018 has been just an amazing year for open source. I think it is where open source has just actually, become the status quo. We've seen some huge acquisitions with the likes of GitHub, even Red Hat, which is one of the largest open source companies around. And I believe, a lot of that is actually a driving factor of a thing called Kubernetes. So Kubernetes, what is it? It's basically Kubernetes is a container orchestration platform. So Docker originally sort of started around about 2013, allowed you to quickly build and test and deploy little container images. Because this was so easy, you could actually build in a lot of these images. You basically needed a process or a system to control and manage these containers. It's not the only one. There are quite a few others out there. Docker Swarm, Rancher, HashiCorp Nomad. out there, but Kubernetes has really sort of stood up, and sort of the way it's structured has meant that a lot of other companies and people have bought in on it. So, quick overview of Kubernetes itself. It was originally a Google project. It was given to the CNCF early on, which I think is one of the critical things of this of its success. It's basically a independent force who can work with multiple corporations and ensure that sort of everyone's voice is heard. It was based on basically Google's Borg system, which is the way they run containers, and I believe they're ongoing trying to backport a lot of the Kubernetes working to their systems. It's only 3 years old. I mean, this is really quite crazy how young it is. When we compare it to a project like Drupal, this is only 3 years old, and it's claimed to be one of the fastest growing open source project with 44,000 stars. So to quickly get involved, what we want to do is basically give you an idea, get some terminology out of the way, so you have an understanding of how we're going through with the project and the demo. So a couple of things to consider here is the components of Kubernetes. So high level, you start off, you often have what's known as a cluster. A cluster because you have multiple nodes or multiple machines within the cluster. And that's one of the benefits of Kubernetes, is the fact that it can easily run and manage and maintain multiple machines at the same time with a single platform. So underneath the cluster, you have what's known as a node. These are usually the VMs, the servers that run the workloads. The workloads themselves run in what's known as a pod, and a pod is the piece that can actually be scheduled out to the nodes. And inside a pod, you can run multiple containers. So that's kind of the breakdown of the hierarchy of how a Kubernetes platform will work. What's important to know is that it's also split up between what's known as a control plane and a data plane. So the control plane itself is the Kubernetes system. It sits there. It's basically an API, a controller, which ensures what it's told to do. It actually shows up and does. It has a whole bunch of components we'll show a bit later. But one of the main things that Kubernetes does, it is you basically declare your configuration to it, and it is constantly what's in a reconciliation loop, ensuring that what you've said you want to run will run. So in this example you see here, it's constantly observing what's running at the moment, diffing it with what you want to run, and then acting and reacting. So it's a really good system in cases of high availability, for resilience, anything that you need that extra control over. So the next step is really understanding, and this is just a quick intro to the Kubernetes resources themselves. This is not an exhaustive list, but is the resources we're going to be using today. We'll talk through. So from a high level, we start off with what's known as a deployment. And a deployment is essentially a object that controls a replica set. The replica set itself, in turn, controls a set of pods. So the replica set can have one or many pods that it controls, and then the pods themselves will be scheduled out onto the nodes. The last thing to understand is that you also have what's known as a service in this model, where we publish a service that knows how to actually talk to the pods that run inside the nodes. So from this model, you can actually have deployments and rollbacks. So in the example here, each time you run a deployment, it will actually deploy a new replica set and potentially a new set of pods, and you're able to also roll back. One of the other major benefits that comes with it is rolling updates. So when you do release that new version of a replica set, it will wait until the pods are up and ready and running before the service actually switches over. So you can actually get sort of zero downtime deployments. So quickly on running Kubernetes, some multiple options here. On your local machine, when you're doing development, you've got the option of Minikube. Also, Docker has now built-in Kubernetes. Example today, we're actually using Minikube. We tried to get it working with the local Docker to reduce dependencies, but you'll see there's some slight ease of use tools that Minikube comes with. Other options are hosted solutions, so these are completely hosted. You don't have to worry about upgrades or anything. Examples are AKS, which is Microsoft Azure, EKS, Amazon, GK, Google. There's also Oracle Cloud and a whole bunch more. There are other turnkey cloud options, which essentially just build you your own Kubernetes cluster. You still have to maintain the cluster itself, whereas the hosted solutions, they can actually run updates on your nodes and things. And lastly, you've got the DIY option where you can actually just totally build your own thing. So a lot of examples, and a lot of people have been playing around with Raspberry Pis and building out that. There's a project called Kubernetes the Hard Way, which is a great sort of intro project if you're keen to get down to that level. So some of the tools that you'll often work with within Kubernetes, kubectl or kubectl. There's a whole bunch of names, but I think the official one's kubectl. Is basically the CLI tool that you communicate with the server itself. Helm is a package manager for Kubernetes. It allows you to actually build and deploy projects, and it uses a concept called charts, which a lot of vendors actually will support charts for their particular products and allow you to install very easily products out to a cluster. There is an official Drupal chart, but I guess these things can be quite opinionated. One of the things you don't necessarily need, but you kind of want to be able to build images with Docker. It's not a requirement. Kubernetes also now supports multiple other containers formats, but Docker is still pretty much the default at this stage. And lastly, if you're developing locally, you can either use Docker's built-in Kubernetes, or you can actually just use Minikube, which has some helpful features along the way. So, with all this out of the way, what we need to talk about is really why. Why are we doing all this extra work and abstraction and things? And the main reason is around being able to be cloud native and really removing and abstracting your workloads from the actual underlying infrastructure. So with that abstraction, it makes it a lot easier to move providers, bail over to different availability zones if you need to. It's that built-in resilience, like we talked about, that reconciliation loop that you get, where if a node goes down, if a disk fills up or something, it can actually respond and actually reschedule your workloads to different areas. It's scalable, and it's sort of built in by default. The pod system will allow scaling up of the pods themselves, and then obviously crossing over multiple nodes as well, which gives you not only the scalability but also the elasticity. So you can scale up and down when you're not using it. So with a lot of these cloud providers that provide sort of per second cost models, this is where you can get a lot of benefits from only scaling up when you need to. It's really built for the the microservices kind of architectures because of that. You don't really want to be scaling up huge big pods. You want to be doing little pods if you can. You can just scale it up a lot quicker and faster. Gives a lot of visibility by running all on the same platform and multiple applications on the same platform. They all use the same sort of tooling and processes. So reporting, things like Prometheus that you get can help a lot with the visibility of what's running in there. It's essentially repeatable, which is a really big one, where you can actually run your local cluster, the deployment process, everything you need to locally, and just replicate that out. You can also, through the use of namespaces, actually have sort of like a dev namespace and a production namespace, so you can actually have side-by-side applications that are running. And last things, we talked about before, it gives you the easy ability to have rolling updates if you need to. So the next section we'll get into is just quickly how I went about sort of building out a simplytestme proof of concept. One thing to note, it's actually less than 230 lines of code and config. Important thing to note there is that some of the design decisions were made due to that, so it's definitely not perfect. But that was one of the reasons for the talk, is that this was kind of like a very, very simple implementation to be able to almost take you through the process of how this might work. So quickly, the goal of this really, with simplytestme in mind, is that we're wanting to provide Helm, essentially a Drupal version, and a set of, or a single composer package or multiple composer packages to Helm, and basically out to Kubernetes, where Kubernetes launches a pod and builds you a brand new sort of Drupal ready to go, ready to install. So that's basically the goal of this. The local requirements we talked about just before. You'll need kube control, Helm. For the example, if you're going to process it word by word and inside the README Minikube, you don't need Docker unless you're going to be modifying things, but it's also useful. So step one will be actually building out the Docker images themselves that we'll be using as the base for the actual Drupal 7 and 8 profiles. So in the project there's basically 3 Docker files, and the reason for this is just to reduce duplication, have a single base image. So the Dockerfile Drupal is essentially like a Swiss Army knife that will run both Drupal 7 and 8, and is all built from the official PHP 7.1 Apache image. And through this process, we basically have the Docker files that are linked up to Docker Hub to automatically build. So whenever you push changes, Docker Hub will build the images, and you're able to download them from that. So in the project, there's those 3 current Docker files, and then we also have a dependency on a single external image for MariaDB, because I really want to bother about dealing with databases in there as well. So the Dockerfile.Drupal, basically, what we do, take the PHP Apache image, we configure Apache, add some of the system packages that you need to for Drupal, add PHP packages required for Drupal, we install Composer, and we install Drush. And so that's going to be the same base process that we use for both Drupal 7 and Drupal 8. For the Drupal 8 itself, you can see here, basically take that base image, we do a Composer create project, which is a Drupal, I guess it's a non-official way of installing Drupal via Composer. So it's out there on GitHub, it's called Drupal project. But we can basically, this will install Drupal inside the image and configure everything. I've just taken out a few lines in here just to slide purposes, but we added basically a default settings.php, and then lastly we drop in an entry point or a startup script, which will actually do the package install for us. So this script here itself is what's immediately run when the container launches. Effectively goes out and looks for a environment variable called package, and Composer just does the installation of that new package. As it stands, you can actually add multiple packages there, and during that require process, it'll actually resolve all the dependencies as you need to. So what we want to end up with here is essentially a way of having two different pods sitting out in Kubernetes world, with the two containers inside each. So for a Drupal 7 project, you'd have that base image D7 and Drupal 8 D8. So that's the next step. So step 2 is getting to that point as well. And what was chosen, I chose basically to use Helm here. Helm allows you to have basically templated manifests. So you can have variables, if you see on the right, that you can define. And then when you run the Helm chart, you can override these variables or even override a values.yaml file itself. And it allows you to just have dynamic Kubernetes manifests. So quickly, the deployment.yaml. So this is the actual template for the deployment. And like I said, I mean, it's hopefully not that scary. I mean, it's all YAML, and the deployment resource itself. The first thing we define is the API version, and this allows for backwards compatibility within Kubernetes as well. So we here in this case we're using apps version 1. That would define the kind, which is the resource type is the deployment. Within a lot of these resources, they have a concept of metadata and labels, and a lot of Kubernetes sort of uses that to be able to match up services, as well as you'll have a deployment resource itself owns a replica set which owns the pods, and these labels allow it to sort of maintain that relationship. So through Helm gives you the ability to pretty much template all this out, and it does it for you. So there's pretty much not a lot going on in that example. Within the deployment, what we do is we normally inside most of these resources define what they are, and then each resource type will have a spec, and this is effectively the deployment will manage the next level. The next level is that replica set. So here we're actually just saying we want one pod, so the replica is 1, and you'll see here the selectors again matching up with its parents. So with the replica set here, we could have changed that to 2, and it would actually create 2 pods. But in this case, we only want 1 for every time we want to launch this thing. So this is the meat of it. This is basically the pod template in here. We've got like we showed before 2 different containers that are running. One's the actual Drupal web server. It's running Apache. The other one is the database. So the database, pretty straightforward. We've just got some environment variables we've dropped in there. With the Drupal itself, we can see here we're actually passing in that package variable here. That's the one where the install script will actually read and install the package that we want to run. Important things to note here as well is the things like the liveness probe. These are things that are built into Kubernetes, which allow the Kubernetes itself to actually test and check that the pod is healthy. So something similar to those few lines, you can actually have a way that it can automatically basically kill itself if that pod or if that container became unhealthy. Kubernetes would actually destroy that pod and recreate it for you. The other important one is a readiness probe, which is almost the same. However, the main difference is that it's the test for when you deploy it, for when the service will actually direct traffic to it. So you can have 2 different ways to define how these probes will work. The resources themselves, you can define limits within a pod, and you can both define limits and requests. So here what we're saying is we want 10 CPU millicores. And this is for pod scheduling, so we want to make sure when the pod gets scheduled that the node itself has enough capacity to basically run the pod. And you can also set limits so that pod can never exceed those limits. The last one to just discuss here is a bit of a helper that we put in, and we've mounted host volume just for the composer cache. And that just means that whenever we run that composer require on a single node, when composer builds its cache, it's actually building the cache on the node itself. So rather than within the pod where it dies and we have to rebuild it and we have to go and grab another cache, it actually saves that out into the node, and that means multiple pods as well, when they get launched, they can actually read from the same cache. So it was just a helper that was added in this case. You can see two ways where that's defined. In the bottom here, we're actually saying where the volume is held, so it's on the host of that path, and we're mounting it in to the container itself. So the last thing we need is just the service we talked about earlier, and this is very straightforward. All we're basically saying is that we're wanting to expose port 80. So the container itself, the Drupal container, will be listing on port 80, and the service basically exposes that port to the cluster at the cluster level. So now we can actually communicate with that pod via the service. So, as you can see, also the labels will all match up. So, which is the important part. When we do run Helm, all of the naming and the labels will match up. So, what we end up with is basically the single command that we can run. Just a Helm install pointing to the chart. We can set the version. So here we can set 7 or 8, and then pass in a package. And effectively running that command, we should end up with a Drupal site ready to be installed. It doesn't install it for you at the moment, but the process, once you log in, install Drupal, you'll see that package is now inside that, which is not the file. So that's really the process, and it was one of the fun things to be able to just check out and be able to develop and see what could be done in that amount of code. So just quickly, we might as well quickly go through a demo and show you what we actually end up with here as well. So if I go back here, let's show you. So just to explain what the setup is here, we've got those local requirements all set up. So we've got Minikube running, and there's a Minikube command just basically to launch a dashboard. So the Kubernetes Dashboard, which is this here, isn't usually on by default in a lot of clusters, so you do have to install it. But it does come out of the box with Minikube, which is nice. We can see here just a good overview of what the cluster is. This is my local cluster. You can see that we've only got a single node, so it's a single node cluster. Inside that node, you can see a whole lot of resource metrics. This will show you, what's actually running on that node, how many pods it can allocate. So you can see here my machine at the moment, or the VM that I've set up, can only basically run 13. 110, but currently is running 13. It also has a whole bunch of conditions. Each node, the kubelet inside each node actually has a whole bunch of tests itself that makes sure that it's ready to be able to schedule workloads on, and it's constantly checking to ensure that these conditions are met. And you can see here that the status false is good, so we're not out of disk, not a memory pressure, and the ready down here is important. So this means that this node is ready to take on and schedule workloads. And we can finally see the actual pods that are running. So important to note that also Kubernetes itself takes advantage of the concept of pods, and you can see a lot of the pods here are actually Kubernetes itself. So you can see the controller manager, the API server, a few other things in there. So that's what we've got set up. If we go down and have a look at what we've got on deployments, we've got nothing there. So it's all clean, ready to go. We should be able to run a quick Helm. I'll boost that up. So this is basically the Helm command we talked about earlier. And if we run that now, on the side, we'll just quickly have a look at the events. So on the right side here, we're running just a quick kube control command just to actually watch the events that are coming through on the cluster. And if we refresh here, we should see now we've got a new deployment created. So you can see 19 seconds old. And through that hierarchy we talked about earlier, so the deployment that got created effectively created this new replica set. So we can see that we've got a replica set with defined one pod that's running. So inside here, the pod that's running is still launching. It's failing its readiness checks at the moment, just because probably the hang on, refresh. The composer command isn't fired. That's funny. When you scale up, it doesn't show. All right. So you can see here that now this is that install process that ran. So we passed it the variable of Drupal token that we installed. The pod picked that up, has run through that composer require command, installed token into this pod. Helm's come back here on this side and actually said that we're all done, the pod's running, we're all good. We've got 2 out of 2 containers that are running inside this deployment, and we can basically jump in here, and we should take us straight into a Drupal site ready to install. So quickly do that, and while we're at it, while that's installing, what we can see here is we can run through here and probably install another one where we go. So if we do another popular Drupal module is web form, we can go and just basically kick off another build of that, and like we'll see back here under deployments, a new deployment has been triggered, and this time it's actually going to be building that image out and installing web form instead of token. So we're able to have multiple versions of this. We'll quickly jump back here once Drupal's up and running. Do a quick setup and install. And under extend, we should now see in this particular one we've got token in there. So winning. So and the same goes to the other one. We can actually install multiple packages in there. We can also, the way this is set up, is actually install Drupal composer packages. Sorry, it's a bit of a just because it's basically passing it into Composer, if that makes sense. So lastly, we'll see Helm's come back. We'll have a new version, brand new version of Drupal. We won't run through. That'll work. And lastly, what we can see here, if we go to deployments, we can just basically clear this all up and kill them straight away. And what we'll see here, these deployments are gone, those pods are gone, and very easy cleanup cycle. So we can basically very easily, quickly launch very ephemeral environments and to be able to test, modules and things. So that's basic simplytestme functionality, or built in 230-ish lines of code. So if you're keen to sort of jump in and test out Kubernetes, it could be a good way to start, just to have a look at what can do. So, quickly on the wrap up. Yeah. So hopefully, if you do, jump in, have a look. Please ping me, and just if you've got any ideas, questions. We do have an issue open on the simplytestme project page, talking about the future of the project at the moment. There are multiple ideas that are being floated around. One of the main issues is the fact that it's a community-funded project, and a lot of the servers at the moment have been donated to the project. So it's kind of difficult to probably set up and maintain Kubernetes on a whole bunch of servers that are owned by different people and different versions and things. So there are a few challenges at place, but hopefully, one option is the Drupal Association, I believe, are looking at Kubernetes potentially for the CI system. So it may be a case that it could be working in there soon. And lastly, things to keep an eye on out there within Drupal world. One thing we talked about was raised around the project actually having official Drupal images. It's something that's definitely in discussion. Often it's very objective as to how your images are set up and what tools you have and modules you want to include. But it could be a good way to be able to run CI tooling and things as if Drupal itself had official images. The Drupal operator, it's at Badcamp a few weeks ago, and this is something we talked about. Is an operator is effectively like Helm inside your cluster, where you actually, rather than having to run commands and having charts that are external, the idea is you have an operator inside the cluster where you actually interact with it via resources. So if you had, in that concept, an operator, we could actually pass it a special resource type called Drupal. And that way we pass Kubernetes an object like this, which is very straightforward. It creates the object, and Kubernetes, the operator itself, goes and does all the rest of it, which is really cool. And operators, I think Nick talked about the Vault operator. It's a very cool concept that is coming along in Kubernetes. And the last thing to look out for is Lagoon. So Lagoon is an open source hosting platform that Amazee.io support, and we're looking very closely at we're currently in the process of adding native Kubernetes support. So please keep an eye out on that one as well. Cool. That's a talk, and thank you very much, guys.
Thanks so much, Tom. Does anyone have any questions? Must be a really good talk.
Yeah.
I was just wondering if the first deployment names were actually set up by the script, or if that's just Kubernetes building them out of nowhere.
So that's Helm. Helm, by default, you can actually pass in part of that command a release name, but if you don't pass in a release name, Helm actually gives you a automatically generated name, which is handy.
So Dom marsupial?
Yeah. So if we do a Helm list here, we cleared everything out, but you can see, it creates some pretty crazy names, which is good.
Like when you're in Google Docs,
yep.
and you're anonymous,
yeah.
the first names, so there's...
Same with starting Docker containers. If you start, anonymous Docker containers, you'll see they always have a name. I guess it's a Helm thing. Yeah.
Any other questions?
You said that Amazee is, with Lagoon, is doing supporting Kubernetes. Are you saying that you can run Lagoon locally inside Minikube? Is that right?
So at the moment, Lagoon really relies on OpenShift, which is a Red Hat distribution of Kubernetes. So they basically it's a extension, so it's a one-to-one match. A lot of that base core Kubernetes functionality is in there, but they do extend it, and so they add few extra features in there. So Lagoon itself requires mini shift, which is the OpenShift variation of Minikube. Yep.
Do you know if that will be able to use like Prometheus and stuff in that implementation?
As a user of Lagoon?
With the Kubernetes integration, would we be able to then have our own Prometheus to look at graphs and stuff?
So right now, inside Lagoon that's running, what we've done is we've opened up Kibana, so allows end users access to logs. Grafana, which would be nice for getting metrics and things. It's not far away. I think we'll get there. And what we've got now is a really nice dashboard. So it's a place that we can expose these metrics and things. Yeah. So.
Great stuff. Thanks ever so much, Tom.
Hey, how you doing? Hi.
Spread the love.
Spread the love, yeah. Get everyone excited. Yeah, well, I mean, that was one of the things here. It's probably like quite basic. I was looking at people in the room, but I wanted to sort of share the love and hopefully get more people excited about it. Really. Yeah.
Good on it.
Yeah.
Really nice.
Yeah. How you going?
I tried Kubernetes on a K8s Prometheus operator. Like
Right. Yeah.
Really
That's
interesting.
awesome. Yeah.
But then I realized I actually need to monitor other resources, not just the Kubernetes. Like when you install Prometheus operator or Keytron, it's actually designed to monitor the cluster itself.
Yes.
And the moment you want to cluster something externally, you have to write templates, which kind of there is a way, but I don't think that's how it was meant to really be.
Well, a lot of that stuff is because we're also using Kubernetes. And we're finding, because there's so many levels of abstraction, right? So you're wanting to create the object, and then how that converts into the actual config,
Yes.
and then how it gets deployed. Yeah, it's quite hard.
Just reaching the conclusion, it's actually better to have like this Kubernetes Prometheus operator is for monitoring the Kubernetes cluster itself.
Yep.
But when
When you're building your own.
other services like your endpoints,
Yeah.
you just have your own instance, like whatever even if it's run on Kubernetes,
Yeah.
it can be like a normal project. Nothing to do with the operator itself.
Yep.
I think.
Well, I mean, you can set up these custom service monitors, and then potentially depends on the app itself. But if that exposes sort of Prometheus endpoints, it can scrape just through a service monitor. So we do that, for example, in our OpenShift cluster. We have.
So what is service monitor? Is it like
It's an object. So the service monitor, it's an object of the Kubernetes operator.
Okay.
So it's a custom set. They call them CIDs. And so it's a custom resource technique called service monitoring. You basically define what the endpoints are, and it talks to the services to find out it's like a big abstraction, but you can actually ship the service monitor in your own application. So you can manage the monitor in your own application, and then the operator sees it, and then automatically configures the scraper.
But it's basically still addressing whatever runs on the cluster, so containers, so like pods running on the cluster, right? But I also have, my original objective was to be able to monitor infrastructure, which is basically not Kubernetes, right? Like also other endpoints, and I realized that I'm solving a different problem, which is very interesting.
Yep.
But it's like, in my opinion, this is
not
not what I want at the moment, right?
No. I don't think it's configured for that, really. It has that abstraction where you can't really properly manage your endpoints. So if you know an endpoint, we found it quite difficult to do that. Because we were actually trying to do that with some certain nodes, and it seemed like wasn't an easy
And then
thing
you
to
need
do.
like IP locking, you need to figure out how to get to Kubernetes cluster behind a static IP address, like outgoing net, and like all these little things that will pop up.
Yeah.
That's very interesting.
So if everything runs inside the cluster, it's kind of
Yeah, that makes sense,
easier,
right? That makes sense.
Yeah, and I guess that's a benefit, and that's where things like I think I just spoke to you about STO kind of
Yes,
shakes it a
absolutely.
bit further. And,
Yeah.
yeah, but I better get out of the way.
Is the Prometheus operator like there was this Helm going?